standard deviation carries with it an additional benefit of using it to describe a variable. And that is that we can get a quick sense as to where most of the data falls within a variable, especially if we are working with what's called a normal distribution or a bell-shaped curve. And as we'll see in future chapters, this normal distribution shows up quite often, depending on the type of statistics you're working with, but it's not infrequent. And so standard deviation's ability to describe a variable is very powerful in those cases. And so we're going to talk about it a little bit here. In later chapters, we'll actually calculate kind of more about why this is true. So the empirical rule is kind of a rule of thumb as to where we can know a lot of observations fall, or a number of observations, or a percentage of observations, I should say. And that's based around, and I'll just flip to the to what your book has, because they do a nice job of introducing it. So the empirical rule is based around, again, a bell-shaped symmetrical data here, right? So no skew happening here. So when we have skew, these percentages don't necessarily, or they don't follow perfectly. So that is one thing to bear in mind. But when we have the symmetrical bell-shaped curve, which again is also referred to as a normal distribution, then we have a good approximation. And what we're seeing here on the screen is that 68, we can say things like 68% of the observations will lie within one standard deviation of the mean. So what we have depicted here is, you can see the middle of the data, the black dotted line is right in the middle. That's the mean, because again it's symmetrical data. It's the mean, it's the median, it's the center of our data. If that's at 100 here, and we are told the standard deviation is 10, we know then approximately 68% are somewhere between 90 and 110. The empirical rule gives us kind of three, or the way it's often described or used is that there's kind of three levels of the empirical rule. So we also know 95% fall within 2 standard deviations, and then within 3 standard deviations, or stretching from 70 to 130, is 99.7% of the observations. Okay, and so we'll return to this concept quite heavily later on when we talk about probability specifically, and then that is used in our testing mechanisms. And so, yeah, this is one of the important concepts that we'll return to, and we'll discuss why or when we can rely on a certain amount of data, or a certain set of data, being normally distributed. And once we can think about this empirical rule more closely again. But to jump back to why we might use standard deviation to describe a variable, again, if we're talking in normal distributions, and you tell me, I have a variable with a mean of 7 and a standard deviation, we can start using the sigma standard deviation of 4, and you tell me it's normally distributed, then I can, in my mind, start to build a picture with a mean of 7, and I know then that a certain amount fall between 3 and 11, and even more, I can go to -1 and 15, and I can start building this picture as to where the data falls. I did not draw that symmetrical, but so when you describe a variable to a person, even yourselves later on in the semester, if you're able to say, here's a mean and a standard deviation, you'll pick up kind of where the data falls. And again, so 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 that's different than if you were to tell me, you know, you have a mean of 6, maybe you have another set of data with a mean of 6 and a standard deviation of 1. Well, that data is going to look differently, right? It's going to be distributed differently. And I can already kind of tell you that that's going to fall, you know, the middle of it's going to be here at 6, and it's going to be a tighter distribution, right? So it's going to look something like that, and probably even taller than that, but you know, it might look something more like this. And so just describing something with the mean and the standard deviation of normal distributions gives us a good feel for the data, and we can be more specific and say, you know, 95% of our observations are between, you know, that would be what, 6 plus 2 and 6 minus 2. Okay, so between, well, wrote that kind of the wrong way, but so between 4 and 8, right? Flip these around. Between 4 and 8, it holds 95% of our observations. And so that's really what the empirical rule buys us, is a way to describe where a lot of the data falls, but and also a way to visualize kind of where the data, how the data looks.